Oke, lalu torsi. Nah, ini torsi. Ya, setiap pesawat akan ada torsi terutama propeller ya, karena propeller kan berputar. Itu ada torsi. Apalagi perputarannya yang di depan nggak, di belakang ada perputaran, itu ada twist tuh. Ya ada. Ini hal-hal semacam ini akan mengganggu atau berpengaruh terhadap prestasi terbang. Kalau ada propeller, ada lagi masalahnya, asymmetric thrust. Ya, jadi karena propeller itu berputar sebegitu di depan lagi ya, jadi thrust yang di kiri sama kanan kadang-kadang berbeda. Atau ya ini at high angle of attack and high power setting. Jadi pada saat angle of attack tinggi, powernya tinggi, ya, descending propeller blade has greater angle of attack than ascending propeller blade. Jadi yang atas sama yang bawah kan posisinya berbeda. Pada saat dia climb, ya tentunya sudut serangnya yang atas sama yang bawah berbeda. Karena sudut serangnya berbeda, makanya ada berbeda gaya. Dengan berbeda gaya akan ada yaw dalam hal ini, akan dia bergerak ke kanan. Jadi kompleks ya, keberadaan propeller itu akan banyak sekali mengganggu prestasi terbang. Lalu ada yang namanya precession. Ya, kayak gasing lah precession itu ya, karena dia berputar makanya akan ada gaya-gaya tambahan. Nah, kita lihat gaya-gaya yang ditimbulkan pada saat propeller itu bekerja.
P factor, also known as asymmetric disk loading, is a left turning tendency resulting from the descending propeller blade's higher angle of attack, which creates more thrust than the opposite ascending propeller blades when the TBM is at high pitch attitudes. The left turning tendency is strongest at lower speeds, such as during takeoff roll, after the pitch of rotation, and during steep initial climbs at lower speeds, such as Vx and Vy. As the angle of attack is reduced, less and less rudder force is required to counteract the left turning tendency. The propeller slipstream exists throughout the speed envelope and creates a nose left turning tendency, which is pronounced at lower speeds and decreases proportionally with increases in speed. Torque influences roll about the longitudinal axis, a counterclockwise rotation of the fuselage when viewed from the cockpit. It is also prominent at lower speeds. Respecting rotation speed and minimum approach speed provides control authority against the effects of torque. Aggressive pitch-up transitions, as in a rapid rotation at takeoff, creates a nose-right turning tendency, gyroscopic precession. The same is true with aggressive pitch-down transitions, as with a brisk stall recovery. But the turning tendency would be to the left. The effect is also more pronounced at lower speeds. Understanding the flight control inputs required to counteract the left yawing tendencies created by P factor and slipstream is straightforward. Right rudder force is required. Gyroscopic precession, another yawing tendency, is apparent during pitch changes, thus it is momentary. Brief right or left rudder force is required. Torque, which is most obvious with an abrupt increase in power, is different. Torque induces roll and is strongest when flying slowly, when the weather vaning properties of an airplane are at a minimum. Earlier we mentioned that the primary flight controls used to roll an airplane were the ailerons, which is true. Unfortunately, ailerons have two byproducts which are undesirable when flying at minimum controllable airspeed. Ailerons increase angle of attack and they produce adverse yaw. On all airplanes, the lifting aileron increases the angle of attack at the associated outboard wing section. Lift is manipulated to roll an airplane. Therefore, if one is truly flying at minimum controllable airspeed, any increase in the wing's angle of attack would exceed the critical angle of attack, resulting in a wing stall. Moreover, if the critical angle of attack is exceeded by the lifting aileron, a stall results and the airplane rolls in the direction of the stall. Applying more aileron worsens the situation. Regarding adverse yaw, when increasing lift, an aileron also induces drag, which pulls or drags the nose of the airplane in the opposite direction to the roll. In this example, if one wanted to roll to the right, to wings level, the nose would yaw to the left, against the desired direction of movement. This is also an undesired effect when maintaining coordinated flight at minimum controllable airspeed. The TBM's advanced aerodynamic design incorporates spoilerons, which assist with roll control and mitigate adverse yaw. Despite this aerodynamic advantage, one should manage propeller's rolling and yawing tendencies by giving the rudder priority for roll control when maneuvering in the low-speed regime. This image of the TBM 850 was taken during the initial stages of the takeoff run. Power is at 100% torque. Soft field takeoff technique is being applied.
Jadi banyak sekali ya masalahnya dengan adanya propeller di depan itu. Tapi kita lihat nih contohnya.
For the purposes of this review, the pitch attitude is set. The indicated airspeed is accelerating through 55 knots. The aircraft is light on fuel. Payload is at a minimum, and only the pilot is on board. Since the aircraft is light, with a high power setting at a low airspeed, the optimum conditions exist for the propeller's effects on the airframe. Can you visualize the angle between the thrust vector and the flight path? In this example, the flight path is the ground run. With power at 100%, the left turning tendency resulting from P factor is at a maximum. With maximum power and minimum aerodynamic control due to the low airspeed, a strong slipstream is curving around the fuselage and impacting the side of the tail, inducing a left turning tendency. With a high power set.
Jadi ada 4 hal di sini yang terjadi kalau ada propeller di depan, ada propeller faktor, ada slipstream tadi, ada yang udara yang berputar-putar ya, ada torsi karena dia hanya berputar, dan ada gyroscopic precision, ya, precision. Jadi ada 4 hal ini yang menyebabkan masalah pada saat ada propeller.
At lower speed, the rolling tendency caused by torque is at a maximum. It is easy to see the wingtip clearance, or look even closer at the difference in the strut compressions. See the rotation of the fuselage. The wide stance of the TBM's main landing gear provides stability.
Ya, intinya itu, Anda bisa lihat lebih lanjut. Ya. Tapi intinya bahwa prestasi terbang itu banyak sekali dipengaruhi oleh elemen-elemen yang ada di pesawat tersebut, terutama kalau ada propeller. Ya, ini ada slipstream. Ya, ada namanya slipstream ya, jadi ada putaran-putaran udara ini yang di ujung ini pada saat dia menyentuh rudder ya akan jadi belok ya. Jadi ada bisa jadi yaw ya, gara-gara ada slipstream. Ya, permasalahan-permasalahan dengan propeller tadi sudah dilihat ya, ada adverse yaw. Jadi adverse yaw itu kalau Anda suruh belok kanan malah jadi belok kiri ya, atau belok kiri malah jadi belok kanan. Permasalahan-permasalahannya kalau terjadi dengan propeller.